Welcome! Today, we're going to break down a tool that's become absolutely essential in the world of modern tech infrastructure, Prometheus. Okay, let's start with a scenario that, if you're in tech, you've probably lived through and it's stressful. You get that dreaded message, users can't log in. The error looks simple, right? But the real cause, man, it could be absolutely anything. And that's the thing, right? In the complex web of modern systems, that can't log in error is just the tip of the iceberg. It's often the last domino to fall in a long, hidden chain of failures. Maybe a server ran out of memory, which then killed a critical container, which then took the database offline, which then crashed the authentication service. Trying to trace that whole mess back by hand, it's a total nightmare. So how do we get ahead of this chaos? Well, that's what we're going to break down. We'll start with the problem, what I call the DevOps blind spot. Then we'll introduce Prometheus as our watchful eye. We'll peek inside its architecture. And finally, we'll talk about the trade-offs, its power, and its price.
All right, let's dive right in. Section 1, the DevOps blind spot.
You know, the thing about modern infrastructure is that it's like a massive, bustling city of microservices and containers. You've got hundreds, maybe thousands of these little processes all running and talking to each other. And any single one of them can crash and start that domino effect we just talked about. If you don't have a way to see what's going on, both on the hardware and inside the apps, you're basically flying completely blind. And that is where Prometheus comes in. It's really become the go-to tool for monitoring, especially in the wild, dynamic world of Kubernetes. It's designed to be the eyes and ears you've been missing.
So what is it really?
Well, at its heart, Prometheus isn't just a fire alarm that goes off after the house is already burning. It's more like a constant security feed. It's always watching, collecting a steady stream of information about your services, ready to tell you the moment something starts to look a little off. And this is what's so cool about it, that proactive power. It's not just about, hey, your server is down. It's about getting an alert that says, hey, your server's memory is hitting 70% and climbing fast. That gives you time to actually step in and fix the problem before it crashes. I mean, that's a total game changer, right? Okay, so let's pop the hood and see how this thing actually works. How does Prometheus get all this incredibly useful data? The whole system is built around the Prometheus server, and you can think of it as having three main parts. First, you've got a special database, a time series database, to store all the metrics. Then, there's a data retrieval worker. This is the part that actually goes out and grabs the data. And finally, there's a web server with an API, which lets you ask questions and get that data back out to, say, a dashboard. So when we say Prometheus monitors things, what are those things? Well, in Prometheus speak, they're called targets. And a target can be pretty much anything you care about in your setup. It could be a big Linux server, a database, or even a tiny single application. And for every target, there are specific things you want to measure. These are called metrics. So for a server, a metric might be its CPU usage. For your app, a metric could be the number of errors it's throwing per second. These are the actual data points you're collecting minute by minute. Okay, but here's a question. What if your database doesn't know how to talk to Prometheus? It doesn't just spit out metrics in the right format. That's where something called an exporter comes into play. Think of it like a translator. It's a little piece of software that sits next to your database, pulls out the information it needs, and then formats it perfectly so Prometheus can understand and collect it. And this brings us to what is maybe the most important design decision in all of Prometheus, the way it collects data. Most older systems used a push model, where every application was responsible for sending its own health data to a central spot. But Prometheus flips that on its head. It uses a pull model. The Prometheus server actively reaches out and pulls, or scrapes, metrics from its targets. This is genius, because not only is it more efficient, but it's also a built-in health check. If Prometheus tries to pull data and gets no answer, well, you know right then and there that service is in trouble. Now, of course, there's always an exception to the rule, right? What about a job that's super short-lived, like a script that runs for 2 seconds, and then it's gone? By the time Prometheus tries to pull from it, it doesn't exist anymore. For these special cases, Prometheus has something called the push gateway. It's basically a little mailbox. The short-lived job can run, quickly push its metrics to the mailbox, and then disappear. Prometheus can then come along later and collect the mail. It's a really clever solution. Okay, so we get the how. Now let's talk about the so what. What are the real-world implications of this design? Because like any powerful tool, it comes with a fundamental trade-off. And here it is, the central trade-off.
On one hand, you have incredible power in its reliability. Each Prometheus server is built to be a standalone fortress. It doesn't depend on a bunch of other services, so it's designed to be the one thing that's still running when your whole infrastructure is on fire. That's its superpower. But that's also its price. Because it's so standalone, getting hundreds of these fortresses to talk to each other and give you one big unified view of everything, that gets complicated. Scaling it can be a real challenge.
All right, to really bring this all together, you have to understand that Prometheus isn't an island. It's part of a bigger ecosystem. You've got the Alert Manager, which sends you that Slack message when something's wrong. You use PromQL, a super powerful query language to dig into your data. And for making it all look good, almost everyone pairs Prometheus with Grafana to build these amazing dashboards. And the whole package integrates seamlessly with Kubernetes, which is why it's pretty much the default choice for monitoring modern clusters. So this all brings us to the big, final question you have to ask yourself. Prometheus makes a very specific trade-off. It chooses ultimate reliability above all else. It's designed to be that one last thing still running when everything else has gone dark. But that reliability brings complexity when you try to scale. So as you think about your own infrastructure, what's more important? Is it having that single, unbreakable source of truth, even if it's harder to manage at a massive scale? The answer to that question really gets to the heart of your entire monitoring philosophy.